Hey guys, 6.2 today, multiplying polynomials. So if you have ever heard the term FOIL before, that is what we're going to be doing today. All right, here we go. Learning targets, multiply a monomial and a polynomial. This is going to be a distribution. Multiply two polynomials, and we are not going to be using binomial expansion this year due to time constraints, so we can take that one off of there. If anybody wants to know about binomial expansion, your math teacher would love to talk to you about it. Okay. So multiplying polynomials, we have to distribute. So distributing into parentheses is going to be a big part of this. When we're multiplying like bases, meaning if you were multiplying an x squared to an x cubed, you add the exponent. So think back to your exponent rules from Algebra 2 and Algebra 1. Always write the answer in standard form. So the biggest exponent goes first, then the next biggest, down to the smallest exponent. All right, so finding the product here. We've got, this is sort of the simple one where we're just going to distribute, right? I've got a monomial on the outside. I've got, in this case, a binomial. In this case, a 4-term polynomial. So what I'm going to do, I'm just going to bloop, bloop that in. And 4y squared times y squared is 4y to the 4th. I'm adding the exponents when I multiply. 4y squared times 3 is going to be 12y squared. Now here, we've got two variables. We're still going to do the same thing. We're going to distribute in to all 4 terms. Sometimes we call that the rainbow method because it kind of looks like a rainbow. All right, fg times f to the 4th. F times f to the 4th makes f to the 5th. And that g doesn't go away, it just doesn't get any exponent added to it because there was no g over here to multiply to it. All right, fg times this term is 2. F times f cubed is f to the 4th. G times g is g squared. Sometimes that's what they call me. Mr. Gron, I'm g squared. Actually, they called my grandpa that because he was Gordon Gron. So g squared. All right, minus 3, f times f squared is f cubed. G times g squared is g cubed. And then last term, f times f. Hopefully that doesn't describe your math career, f times f. And then g times g cubed is g to the 4th. Yeah, come on. Okay, so multiplying two polynomials, in this case a binomial and a trinomial. There's a couple of different ways that we can do this. One of them is using the FOIL method. The other is using the box method. And I'm going to show both. I'm going to show the FOIL method here. This works really well when you're multiplying by a binomial to whatever because it doesn't get too messy. Once you get to bigger ones, then it starts getting messy. So FOILing, we would bring the first to all 3 terms. And then we would bring that second one, also distribute it to all 3 terms. And what this ensures is that each part here is getting multiplied by each part there. That's how multiplying multi-term pieces works. Okay, so x times x squared is going to give us x cubed. X times 4x is going to give us 4x squared. And x times negative 3, negative 3x. 2 times x squared, 2x squared. 2 times 4x, 8x. And 2 times our minus 3 is a minus 6. Last thing, I got to combine like terms, and I want to answer this in standard form. So my highest degree is x cubed, and I only have that one. I've got a 4 and a 2 for my x squared, so that makes 6x squared. Takes care of those two. Then minus 3 and 8 for the x's makes a 5x. And last but not least, well, last and technically least, is that minus 6. there's some happy little animations in the PowerPoint. Okay, finding the product here. So now we're going to use what's called the box method because we're going to put this into boxes, and one of them is already filled in. This is a really nice method because if you try to FOIL this with 3 of them, it gets really, really messy. And it can be done if you're really neat about your work and can keep track of everything, but it's easy to make mistakes. It's a lot less likely if you use the box method. So what the box method involves is we're going to take one of these trinomials and we're going to list the terms next to these boxes on the outside. So we'll put y squared, negative 7y, and positive 5. And then we're going to put these ones across the top. And it doesn't matter which ones go across the top and which ones go down the side, as long as you don't mix them up, right? All these ones went across the top, all these ones went down the side. All right, so now how we fill in the box is we are going to take the product of the adjacent, of the terms that line up for that box. So in this case, the y squared and the y squared meet here, and that makes y to the 4th. Y squared and negative y meet here for negative y cubed, and y squared and negative 3 meet here for negative 3y squared. And we can fill out the rest of the box the same way. Negative 7y and y squared, negative 7y cubed. Negative 7y, negative y. Be careful with your negatives here. Positive 7y squared, negative 7y and negative 3, positive 21y. All right, 5 and y squared is 5y squared. 5 and negative y, negative 5y. And then 5 and negative 3 is that negative 15 that was already in there. Now, what you do at this point is combine like terms. A lot of times with these, it's really nice because the like terms line up diagonally. Not always the case, though. If we were missing a power, so let's say if this were cubed instead, then they wouldn't all line up diagonally. If it's nice like this, where it's 2, then just y, then no y, y squared, y, and then just a number, so they match, then things line up diagonally. Okay, so our first one is going to be y to the 4th. Then I've got a minus y cubed and a minus 7y cubed to make minus 8y cubed. Then across the middle, I've got negative 3 plus 7 plus 5 for the y squared, and that makes a plus 9y squared. 21y minus 5y is plus 16y, and then the last term was minus 15, like that. Oh boy, look at all those animations that Miss Summer put in here, and I didn't even use them. Okay, so now we've got a few slides where it's going to be some practice problems, so feel free. This would be a good point to pause, try it out, and then see it done here when you're ready. All right, so this one we're going to distribute. 2x times 2x squared is 4x cubed. Here is minus 10x squared, and these two makes 12x, like that. Look at that, I got it right. All right, this would be a good one for FOIL. And you can use the box method here too. It doesn't really matter. I tend to just show this way for this type and the box method for the other type, just to kind of keep things a little simpler. So x times x squared is x cubed. X times 2x is 2x squared. X times minus 1 is minus x. Negative 3 times x squared, negative 3x squared. Negative 3 times 2x is minus 6x, and negative 3 times negative 1 is a plus 3. Combine like terms. X cubed is all alone. 2 minus 3 makes a minus 1x squared. Takes care of those. Negative x minus 6 makes a negative 7x, and plus 3 at the end, like that. All right. Fun one. So a foiling one where we've got two variables. So pause this and try it, if you dare. I guess I could have left that in from the last one, the little arcs. Okay, so 2m squared, 3n squared. 2 times 3 is 6. M and n do not combine. They just kind of go next to each other. All right, 2 times 6 is 12. M squared times m is m cubed, and we also have an n there that doesn't go away. And then 2m squared times negative m squared makes a minus 4m to the 4th. Then taking on the red ones, n times 3n squared plus 3n cubed, n times 6mn, 6mn squared, and n times negative m squared minus m squared n. Now looking at this one, there are no like terms. If there were like terms, both the letters and the exponents have to match. So there's no other m squared n squareds in here. There's no other m cubed n's in here. And that's the same for all the rest of them. So no recombining on this one. Sometimes students ask about standard form in this case. There is a standard form for this. It's complicated though. We're only worried about it if it's a single variable. So don't worry about it if there's more than one letter. All right, a couple more. Try that one out for size. Pause and check. Hopefully my blue marker lasts. I wanted to use the red for the bottom ones. All right, 3x times 4x squared, 12x cubed. 3x times 5x, 15x squared. 3x times negative 2, minus 6x. Negative 2 times 4x squared minus 8x squared. Negative 2 times that one, negative 10x. Negative 2 times negative 2 plus 4. Be careful with your signs. All right, combining like terms, 12x cubed, boom. 15 minus 8 is 7x squared, boom, boom. Negative 6 minus 10 is negative 16x, boom, boom. And then a plus 4 in the end. Ooh, this one's kind of scary looking. It's just a distribution one, so it's not even a foiling one, but it looks kind of frightening. So let's move that into all three terms. 4 times 8 is 32. X cubed times x squared is x to the 5th. Y squared times y to the 4th is y to the 6th. 4 times negative 3 is negative 12. X cubed and x cubed is x to the 6th. Y squared and y is y cubed. And our last one, 4 times 4 is 16. X cubed times x is x cubed. And don't lose the y squared just because there wasn't a y with that term. All right, I think there's one more. Oh no, there's two more. So what happens when we do this? So we're not doing binomial expansion. However, we are going to do some problems that look like this, where instead of being multiplied like this polynomial times this polynomial, what happens when it's this polynomial squared? Well, let's think about that. What happens when you square something? You're multiplying it by itself. And so this is really 3x plus 2 times another 3x plus 2. If we give her one of these, it's going to be 9x squared plus 6x plus 6x plus 4. And now we've got two like terms that we combine, and it's 9x squared plus 12x plus 4. All right, so that's all well and good for squaring. What about higher exponents? What about something like this, y minus 8 cubed? Well, it's really the same idea. And we're not going to get beyond something like this where it would just be ridiculous, like y minus 8 times 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 y minus 8. 3 is probably going to be the max that we're going to do. All right, so when you cube something, you are multiplying it by itself 3 total times, right? So now we're just going to have to break this up and take it in parts. I'm going to multiply these two first. Actually, I'm going to multiply these two first, and then I'm going to multiply whatever that product is by that one. So first off, we're going to FOIL this, just these two. So this is going to be y minus 8. This one doesn't change yet. We'll get to that in a second. And then it's y squared minus 8y minus 8y. Negative 8 is plus 64. Okay? I can combine some like terms there. Y minus 8, y squared minus 16y plus 64. This is where it's really going to pay off if you do your work neatly. Because now, to finish this, we're going to multiply this y minus 8. Like that. And then have to combine like terms and finish it off. So y times y squared is y cubed. Y times negative 16y, negative 16y squared. Y times 64 plus 64y. Negative 8 times y squared minus 8y squared. Negative 8 times negative 16, 80 plus 48, 128. And negative 8 times 64, 480 plus 32 is 512, so minus 512. Yeah, I just did that in my head. I know you're super impressed. All right, combining some like terms to finish this. Y cubed, it's the only one. Negative 16 and negative 8 makes a negative 24y squared. Takes care of the squareds. 64 plus 128 is 192. And then minus 512. Like that. All right, so email us if you have questions, and we'll review. The next day is review, and then a quiz on this stuff. So let us know what's giving you problems.